today is Diana Mutheu. She's an associate data scientist at Roche. So as an associate data scientist, she supports a postdoc data scientist in a project to predict cardiac adverse events using machine learning algorithms and electronic health records data. So prior to this, Diana has worked with healthcare startups on projects using AI. She's also an instructor at Code for Girls in the UK, where she gets to teach and help young girls transition into data science, and also has taught on the same at Africa Data School. She volunteers as a Google Women Techmaker Ambassador and a Women in Data Science Kenya community organizer. Diana is currently at the onset of a Masters of Science in Artificial Intelligence at the University of Hull and looks forward to write papers of research in healthcare and AI. It's now my pleasure to welcome Diana on board to get us educated on matters Python. Welcome, Diana.
Thank you, Brian. I think if you can hear me, we can get started. So it will be a very swift introduction to Python and data analysis libraries. So the first thing we'll look at is the Python basics, the libraries for working with data, that's NumPy, and then libraries for, again, still working with data, that will be the second will be pandas. And then just a swift also introduction with the visualization libraries, that's Matplotlib and Seaborn. But according to what we have lined up as the Women in Data Science, it's a series of events that happen every month, every last Tuesday of each month. So we'll just go elevating as we proceed. So Python was, I think, established by Guido van Rossum, and then it is a general purpose interpreted, interactive, object-oriented, high-level programming language. And it's quite readable and very easy to use in terms of having it as your first language, right? Because of the English words that are used quite frequently. And then so basically how programming works, that is how it actually works, but without the compiler for Python. So Python uses an interpreter. That kind of makes it a bit slower because you kind of need to define quite a lot for it to be translated to zeros and ones and then executed on your end. And then applications of Python. So we have web development, game development, machine learning, which is the core of the series that we have, the data drill series that we are having, and then data science and visualization. We'll look at just a swift introduction of two of the first libraries, and then web scraping, where you get data from the internet. So these are some of the major companies that utilize Python in their source codes of the programs that they have built or applications that they have built. And then, so what we look into in terms of Python, we look at the comments, variables, data types, functions, and modules, what they are, and just a swift or a smooth kind of explanation of what they are on the basics. And then we do have NumPy, which is essentially a scientific computing numerical Python library. So NumPy basically is way faster in terms of performing any numerical or mathematical functions in programming, right? Because as you know, as a data scientist or a machine learning engineer, there's quite a lot that you need to calculate in your day-to-day problems. This is the library for you. So algorithms plus mathematics, you get an AI. So an algorithm is a step-by-step problem, is a step-by-step process to solve a problem. You combine this with mathematical functions, you create an AI model, right? Or an AI algorithm. So again, still with NumPy, these are the builds of NumPy. We have a scalar, a vector, a matrix, and a tensor, right? So when you're working with NumPy, it works with different data structures, right? So you have a scalar where it's a 1D, then a vector, a 2D, then a matrix. And then finally, you usually have a tensor. So tensor, you know of TensorFlow, so it works with tensors quite a lot. And then, so the first thing you're supposed to do, just as the normal thing, is installing the library. We look at how to do that. Then you import it, check the version just to confirm if everything is right. So if you're in a Conda environment, then you do not need to do the first step, but I'll just do it for demonstration purposes. So what we look at in NumPy is the NumPy arrays and how to work with it, and basically very basic mathematical operations with NumPy. Then we have pandas. So pandas is what we use for data analysis and in manipulation, and is built on top of the Python programming language. It's used to handle this kind of data structures. So you have an index, which is usually the first row of your data set. So your data set is usually tabulated when you're using pandas. So you have your rows and your columns, and then each column is a series. Then when you combine rows and columns together, you get a data frame. So the same drill when you're working with these libraries, you install, we'll see how to do that, import, check the version just to ensure everything is right, and then you can start kicking with it if you want to do your analysis or manipulate your data in any kind of way. And then what we look at are the pandas data structures and how to work with pandas. So we'll get into the code, and do not forget that what we look at today is just the basics of it. Make sure you join our future sessions just to get a little bit more in depth. All right, so let me share my book. Okay. All right, so just zoom in. So the first thing I think I always say is save yourself many trips to Google with documentations, right? So chefs have their cookbooks, drivers have their manuals, developers have documentations. So look at your Markdown cheat sheets. I have attached this. We'll attach this to a GitLab. And then we have what Jupyter notebooks are. I won't get so much into this, what Python documentations are, and then NumPy documentation. Basically, this is what the developers write when they build the library or the language, right? So it's basically a guide on how to use NumPy or Seaborn or Matplotlib. Right. So the first thing we're going to look at is an executable part of code. So in case you need to write notes in your code, or to just write guide notes in your code, we use what we call comments. And how to do that, you create a hashtag and then pass in whatever you need to pass in. So if I run this, basically, you can see there's no output at the bottom. So that means that this part is not executed, but whenever anyone comes here, I can just read it and understand what that is. We'll see how I've used comments as we proceed. Then if you need to write a multiple line comment in Python, we use the three quotation marks. So if we run this, that is what we end up with. Then the next concept is what variables are. Remember, again, it's just a swift introduction. So variables are essentially containers to store data values in the memory, right? So remember, you're working on a computer. We need to store 1, 2, 3 items. So we store them using variables in programming. So at this point, I have x equals to 5. So having x equals to 5 at this point, if I run x, or if I call x, if I print that out, I get 5, right? Why? Because that's what has been saved in the computer memory. And then the next thing, if I store the first name, Emma, if I store Emma in the first name, this is what I get. So basically you just need to call a name, create a name, and then store a value inside of it using the equal sign that is assigning it. And then since we are using a Jupyter Notebook, which is an interactive, which is an IDE, but a web-based interactive IDE, we don't actually need to print items. It will print automatically, but the print function is one item that we use to display elements in Python. So if you run that, you get Emma being printed out, right? You can check other types of IDEs, whether it's PyCharm or VS Code, and text editors such as Vim. I think I've forgotten the other one, but yeah, you can check them out. And then we can now look at data types. So we have various data types in Python. What are data types? Basically, when you're storing something within a variable, it has a type. It's either a number, it's either maybe a date time, right? It's either a name or a letter. So when we have that, we call that a data type. So each programming language supports different data types. So for example, we have strings. A good one is what we've already given up here. That's Emma. And for the string on here, you have to quote it. You have to place it within quotation marks, either single quotation marks or double quotation marks. This changes with every programming language. For Java, this means a single character. And this means a double, many words, many characters, right? But in Python, either one could do. So if I run that and I check the type of this data type, or whatever has been stored inside the first name variable, I get that it's a string, right? So to check the type, you just need to use the type function. Then this is just a by the way, if you need to check what functions do or what, so let me try, for example, type, to kind of sort of get, to get a display of what this is in Python, you just need to run that to understand what a string is or what has been displayed down here. Just call this the help, then pass in str, and then down here it will give you a documentation of what the class string refers to. So you can always use that in various situations. Then we have what we call concatenation in Python. So concatenation is basically joining two items together that are strings, right? So we stored the first name as Laura, and then the last name is Cheese. And then if I run this, I get Laura Cheese. And then another thing in Python or in any other programming language is that a space is counted as a single character. So if I run that, it should now create the space between there. All right, so let's try now and create an integer. So an integer is basically a number or a whole number in Python. So we have the name on here is Alex, and then we have age is 20. So let's try and create a full sentence while concatenating all this together. So we're going to create a string or print out a string. Hello, my name is so Alex, and I am 20, right? So if I run this, I get that. So at this point, when I'm using the str, right? Remember this is age, or this is an integer, so that I can convert it and be able to concatenate it. Remember, concatenation, as I mentioned, is when you're putting two strings together. So when I have the string or need to pass this string into an integer, we can do this. So just call the str, then pass in age, and this will automatically be added. So let's try this without the passing in, and you'll see that we'll get an error, that there's a type error, you cannot, you can only concatenate strings together. So to remove that, you just need to pass it into a string. All right, then we can now check the type of age, and you can see it's an integer. And then at this point, we can check how to use f strings. So f string is also another way of adding or placing elements within a string, right? If you need to, in short, it's another way of concatenating. The difference between all these ways is the speed that it takes. And the fastest one is usually the formatting process. So formatting using a function, an inbuilt function, is way faster compared to either passing. Passing takes a bit of some time because it has to pass it into a string first. And then the F string has to actually check what value it is and then convert it and then now display it. And then the format, it will definitely know that it just needs to format onto this point. So we have also how to use the format, the dot format function. So that's hello, my name is, and then pass in where open brackets where you need to add in the name, and I am, and then open another curly brackets, and then dot format. However you pass this in, that will be arranged exactly how you have put it on there. So if I run X, you can see, hello, my name is Alex. Wait, did my age change? Let me see. So let me run this. I don't know why my age changed. Age equals to 20. Okay. Need to have one there. Yeah, no, it's fine. So that's because I had put numbers on here. So 0 stands for this first one, and then 1 stands for this second one, right? And then I could also print out Y without specifying where it's supposed to be located. If I run this, then it's still going to be the same, right? Because it's automatically going to place the first item here in the first curly bracket and the second item in the second curly bracket. And then the last item, let me do that one. So you can also either pass in the name on here, right? Okay, put in the name in the first bracket and then the age on here after I've already specified it in the dot format. So name equals to this and then age equals to that. That's what I get. Right, and then methods. So what do we mean by methods in Python? So a method is basically a function that is specific to a given data type. For example, we look at one example. So first name equals to Mary. If I run this, and then if I run first name on here, we get that first name is Mary. Now we can use the dot lower, which is a method, which is a string method to convert everything into small letters, and we get that that's Mary, right? There are several functions. There are several functions to work with, there are several methods to work with a given data type, right? So not just lower, you can look into more. And then we have integers, which are whole numbers. So we have x equals to 1. So if I run this, I get that. And then type equals to x. If you need to add up to numbers, x equals to 2 plus 2. Integers can be added. So in this case, you're not concatenating, but we are summing them up, right? And then x will be 4, the sum of those two. And then we also have a data type called floats. And then floats equals to decimals or numbers that are not whole numbers. And then x equals to, for example, 2.5. Plus 5.2, for example, right? Whatever we get in return will be a decimal point number, right? So if I have x here, I get 7.7. So if I check the type of x, for example, type, which is our function to check the data type of x, I get that it's a float, right? Why? Because it's not a whole number. Instead, it has decimal points. Right, and then we have what we call lists. So, and basically lists are usually enclosed in square brackets, and they store multiple items. And then 3 items that you need to master about lists is that they are ordered, changeable, and can contain duplicates, right? So for example, I want to store bananas and apples, or a list of fruits, right? I can do that with what we call list. You just need to open a bracket and then put in whatever is needed. So if I print that, this is what I get. If I check the type, that is what I get, that it's a list, right? And then another thing, remember that list can also take in whichever number of whichever data type. So if I also put in 2 here, it's also fine, right? Okay, it can have be as wild as you want, right? So you don't have to be specific to a given element. And then if you want to do what we're calling indexing, or extracting an element based on its position, that is possible using lists. And then, so if I want to extract the first element, programming indexing starts from 0. So this is 0, 1, 2, 3. So if I want to extract the first element, I just need to call in the variable name, and that's fruits. And then I pass in 0. If I want the last element, I call in fruits and then pass in -1, sorry, and that should give me 2 because that's the last element at the end. And then remember that lists are changeable. So let me try and change this. So fruits, I want to pass in a different element at the second position and pass in mango. So if I run this and then I run that, you can see that at the second position, that's 0, 1, 2, we have mango being passed on there. Then we move on to tuples. And these are enclosed in parentheses. And just like lists, they store multiple items in a single variable, right? So if it's fruits, you have many items, but the only difference is that this time they have circular brackets or parentheses, and then in a single variable, and are ordered, unchangeable, and allow duplicates. So the difference between list and tuples is that one is changeable and the other one is unchangeable. So let's see that, just passing the curly brackets to what we had, and you have a tuple. So we run that, you have a tuple, and then if I extract the second item, if I try maybe changing the second item, the element in the second position, and adding in a pair, if I run this, I'll get a type error, and it will clearly tell you that tuple object does not support item assignment. And then finally, we are almost the final item, or the final data type. We look at sets. So sets are enclosed with curly brackets, and they also store multiple items. But again, how are they different from the tuples and the lists? Is the fact that they are unordered, unchangeable, and indexed, and do not allow duplicates. So that means you cannot call elements based on their positions. You cannot add elements into the list, into the set, like we did to the list. And you basically cannot have duplicates on there as we can have in the lists and in the tuples. So by duplicates, we'll see what we mean. So we have the mixed sets, pass in that, and then if I run this, that is what I have. Checking the type, we see that the type is a set. Let's try and change the item at 0. We get an error. Let's try and add in the word name twice, or 2.5 twice. And let me see. Why did it pick a duplicate? Not quite sure it picked a duplicate there. Let me try and add one. Oh yeah, so 2.5. So if I run this and then I run that, you'll see that it will automatically remove this 2.5 because it already exists on there, right? So it basically does not, it cannot store duplicates, Right, so finally we have key value pairs. That's what we call dictionaries. So when you're storing key value pairs, your key is usually on the left-hand side of the screen when you're facing the screen, and then the item or the value to this key is on your right-hand side. So in this case, I'll have, it's again curly brackets, just like the set, but the only difference is this semicolon on here, the full colon, sorry, to divide the key and the value. And again, dictionaries are ordered, they're changeable, but also do not allow duplicates, just as sets do. So if I run this, then I can store a number of elements about a student. So this student one, maybe the name is Alice. The course is biology, and then the marks, this person scored 85. So if I run that, I have created a dictionary under the variable name student. So if I run that, I get that it's a dictionary type. And then if I need to extract elements from a dictionary, we use the keys. Remember, with the list, we're using the position, and that's either 0, 1, 2, 3. So in this one, we use the keys. So if I want the name, I extract that. If I want the marks, I extract that. And then if I want students and I try to use the positioning, then I'll definitely get an error because we use the keys to extract. Also change dictionaries. Remember, they are changeable. So let's try and change the age from the age was, oh sorry, let's try and add a new key value pair and have age being added. And remember, when you add something, it gets added at the end automatically. So if I run that and then that, we can see that a new key value pair has been added, and that's age 15. Right, and then we look at what we call loops. It's a slash or a slight view. So loops are basically mechanisms for iterating over a number of items, right? So for example, we have, we've already looked at what lists are. So students equals to Emma, Sandy, Sarah, James, and Ethan. So let's try and print every single name out of this. So we can use a for loop. There are two types of loops. So we have for loops and while loops. So for pupil in students, we're going to print each pupil name, and this is what we end up with. This is what we end up with. So we have Emma, Sandy being printed out at the end. All right, yeah, so that's basically still printing. Okay, so if you want to check how long your list is, for example, in this bit, you just need to use the function len, then run that, and you can see that we have 5 students. Or another way of creating a loop is using the range of the length of students. So basically what this says is for each element in the range of the length of students, that's 5, we're going to print out each student, and we end up still having the same thing. And then the second one is what we call a while loop. So a while loop, basically you start with a condition. So we're going to start counting, the count is going to be 0. Then while count is less than or equal to 10, I think you already know what this means based off mathematics, less than or equals to, and then open a bracket, set in your condition. So basically, just remember, a loop is an iterative form of item. So it's going to iterate until you tell it to stop iterating based on a certain condition. So we're going to print count. Remember, we used f strings on top there, and then pass in count, the new number of count. Then here we have an incremental sign where it's going to sum up each time this condition is met. So every time count is less than or equal to 10, it's going to display the number on here also until this condition is not met. So that means when you get to 11, then our loop is going to, when we get to 11, our loop is going to break and will not increment by 1. Why? Because this condition will not have been met. So if I run that, we get 0 to 10. All right, and then we look at what we mean by conditional statements, right? So a conditional statement, just as the name says, you set a condition, and if that condition is met, then a certain action is going to be executed. So in this case, we're going to store two items in X and Y, right? So X and Y variables, and that's 10 and 12. And then we're going to try and print in or set in a very simple condition using the if statement, right? So if statements, if else statements are used to create conditions in Python. So if X is greater than, again, this sign, than Y, then we're going to put a condition down here. Oh, sorry, what is going to be done if this condition is met? We're going to print, again, the F string. We're going to print that X is greater than Y. Yeah, so if, okay, so let me pass in 12 here and then 10 here, so that at least our condition is met, and you can see that 12 is greater than 10. Then adding in another else statement. So an else is if the first condition is not met, then we're going to close off our conditional statement using an else. So if X is greater than Y, this is going to be printed out. Then if the opposite is true, then the else statement is going to be executed. So if I run that, of course, the top will be executed, right? But let's return it to how it was. So we have 10 and we have 12 here. So if I run this and then I scroll down and then I run that, we can see that the else statement has been printed because the first condition was not met, right? So that's the purpose of the else, to close off your conditional statement if the first one has not been met. We also have the elif. So the elif is usually added just to check, to add other conditions, right? And if all these conditions are not met, so you can have as many elif statements as you want, just one if, as many elifs as you want, unless the ifs are nested, and then the else should just be one to close it off. So if I run this again, the last one, the else will be printed because 12 is greater than that. So let's try and have it as 10, 10, so that we see the elif being executed, hopefully. So we run that. I did not execute this. And then I run this. And we can see the elif being executed. 10 is equal to 10. Right, and then we have what we call logical operators, which are used to combine conditional statements, right? So the conditional statements are what we have up here. And then now let's try and see how to make a couple of those together. So now we have 14, and then we have to use and, right? So we have and, or, and not in logical operators. So and basically both statements have to be met for the condition to be, for the result to be executed. So if X is greater than 4 and X is less than or equal to 12, then this statement is going to be printed out, and that's not the case. So we do not have that being printed out because our X is basically 14. In this case, X is 14, right? So it is greater than 4, but definitely not less than or equal to 12. Put it like this, then our statement gets printed. Okay, we can have it. Yeah, we can have it like that. And then let's try the or piece. Let's return it back to 12 so that you see that it will actually execute the statements just because it's an or statement. So if we are working with an or statement, either one of the conditions is met, then we're going to run that and get the fact that hold on 1 minute. Oh no, it was 14. It was 14 initially. Yeah, so let's do it like that. Yeah, so in this case, with an and, nothing gets printed, but with an or, it gets printed because the first bit is met. So 14 is greater than 4. And then the not is basically just what we're saying. So x equals to 14, y equals to 10. If not x equals to, so if you're the single equal sign is an assigning, is used to assign a value to a variable, and then the two equal signs are used to check if two elements are equal to each other. So is 10 equal to 2, is 12 equals to 12, and so on. So if not x equals to y, in this case our x is 14 and our y is 10. So if we run this, we'll definitely get that 14 is not equal to 10, right? Because this condition has been met, they're not equal. So we print out that item. So let's have 14 and 14 and nothing will be printed out. So you can either use not or this sign, the exclamation mark or equal sign. I think again in mathematics or physics, this is actually used. All right, yeah, then the same condition on there. Right, and then what is a function in Python? So that's basically, we've already mentioned what methods are, which are basically functions for a given data type. I've mentioned functions quite a number of times, and that's basically a reusable piece of code to perform a given task, right? Creating your own function. So we have inbuilt functions like the dot lower that we used, and then we can create our own function that's using the def or the definition in short, and then the name of your function, the parameters that it expects. If it expects 2 or 3 items, then the full colon, and then what the function is supposed to do and what it's supposed to return, right? So in this case, it's taking in one number and the second number, and then returning number 1 plus number 2, and then returning the total sum. Basically, that tells you this function is going to sum up two elements together, and you can reuse this as many times as possible, because remember, it's a reusable piece of code. So if I pass in 90 and 40, I get the total of these two. If I pass in 190 and 80 and 89, I get the total of that too. And then finally, we have what we call modules. So modules are basically a file that contains a set of functions, right, compiled together. So for example, on here, a very good module that is well known, especially in data analysis and manipulation, is the date and time module. So we have import date and time. You always have to import your modules and your libraries. And then from date and time, because remember, a module is a file containing a set of functions, then you call in the function that you require to use. And in this case, I'm using the date, and then import time. Time is also another module. And then from time, we're going to import time, right? Just to test this out. So we're going to start with date. So the today's date equals to date, this date that we imported on here, then dot today, because today is also a function that exists within date. So if I run this, I get today's date as 2023, the 2023 6th month on the 27th day. And then let's try timestamp. I'll get today's timestamp, but it will be in seconds, milliseconds. Yeah, it's the from seconds and milliseconds of the time that is on today, but it should be 8:46, right? So yeah, that's also how to work with this given time function that we have imported. There's so many modules that work within Python. Right, so now we move to NumPy. So NumPy is, as I mentioned, how it works with the scalar, the vector, the matrix, and the tensors. So these are basically the building blocks of NumPy operations, right? Or we can say the data structures of NumPy. So the first thing, again, importing numpy as np. Np is just a universal alias that is known to represent numpy, right? So if you ever see np being used, just know that that's numpy. So let's try and create a scalar. So that's a zero dimensional array, what we call scalars. Sorry, so array equals to np.array, then pass in your number, that's 42. So np.array converts that item into a numpy array. So let me rerun this. I did not import that. Yeah, and then we have 42. Then the next one, let's try a vector creating one. So if I run that, so basically passing in a list on there, and you can always check the type. So in this case, I think it should be type or D type. Array, if I run that, it tells you that this is a numpy n-dimensional array. Then we have a matrix, basically passing in two lists within a list, right? So that will create what you call a matrix, and then a tensor, passing in lists stored inside a list in a larger list. So you have two lists storing multiple lists on there. Also just count the number of outer brackets. So this is 1, 2, 3. This is 1, 2 brackets. That's kind of how you know. I think in high school we worked with matrices quite a lot, right? And then how to do simple mathematical operations. So you can basically create a simple array of 15 numbers, and that's using the np.arrange 116. So passing in, again, this is what we call it, a method within numpy, right? So 1 will be the starting point, and then the ending point will be 16 not included. So we'll have 15 numbers being shown out there. So let's try adding or summing up to arrays, and that's nums plus nums. So in this case, it will be the first number. So because you're adding this to itself, right? So it's going to be 1 plus 1, 2 plus 2, 3 plus 3, and so on. So this is what we get, an array of 15 numbers still, but each number summed by itself, right? So if it's 1 plus 1, 2 plus 2, and so on. So that's how you get to sum up two arrays together. If you want to add a number to the to your array, right? Let's say I want to make every element plus 10. You just basically need to call your number to store it inside a new variable, and then equals to nums, where we stored, that's the array we created up here, plus 10. So basically this array up here, the 1 to 15, and then plus 10. Then we after we run this, we get each element starting from 1 to 15 plus 10. There's so many functions within NumPy. You can also do the square root, right? Because remember, NumPy is your numerical mathematical library. So if I need to do the np.square root, then pass in the nums, which was our number 1 to 15, then you're going to get the square root of each number, and that was 11, 12, 1, 2, 3, and so on. Right, so the other thing we're going to see is how to check how many dimensions you have, right? So I'm going to store a number of items in X, S, and in YS. So a list, right? So a list of 1 to 5, and then the second on a list of 5, 4, 6, 5, 6. So if I run this and then I check the types of each, basically those are lists. So let's see how to convert lists into arrays, because you'll do this quite a lot. So working with lists is quite slow when you're using loops, but when you involve NumPy, it becomes a bit faster. So we have np.array, pass in your list, and then the data type as np.float or np.float, and then 64 is usually the number of bytes that it occupies in the memory, right? So we've rechecked the dimension because we've already converted it into an array using the np.array function. So numpy.array. So basically the .array function. If I check the dimension, we can see it's 1. If we check the type again, we can see now it's an array as compared to being a list as we did before. Right, and then finally, oh no, yeah, one more. So pandas, now we look at pandas and how to work with pandas. So pandas is, as I mentioned, your data analysis and manipulation library, right? So if you do have Anaconda or you're using the Conda environment, please make sure you check out what that is. Then you definitely do not need to pip install. But if you're installing in the Jupyter environment, in your Jupyter notebooks, this is how you do it. Normally in Python, you just do the pip install, and that should do it for you. Sorry, and that should do it for you. And then after you've installed, so if it's installing, same to NumPy, you just need to pass in NumPy. Then import pandas as PD. That's the alias, the general alias for pandas. So if I run that, it might take some time for it to confirm. Yeah, and we can see that that is installed. It will tell you that the requirement is satisfied if you already have it. And then we can see that the pandas version is 1.44 that we are currently using. All right, so as we said, when working with tabular data, that's when we use pandas, data that is either stored in relational databases or spreadsheets and so on. Right, so let's create an empty data frame. So to do that, we call in PD, which is our alias after importing the data frame, .data frame. Then if I run that, we have basically an empty data frame created. So we can populate this using items. Oh yeah, so first we can create a large list of elements, not list, dictionary of elements, where we have the name, the marks, and then the gender. So we have the first name, so the first person, that's in the first string, the second string, and the third string, and the first mark, second marks, and third marks, and so on. And then male, male, female for each respectively. Then to convert these students' dictionary into a data frame, again, we just need to call in PD, which is our pandas alias dot data frame, then data, passing data, which is a parameter inside the dot data frame class, equals to students. So if I run this, this is what I end up with, a clean data frame with the first name, the first column being name, second being marks, and then the final one being gender. So if you need to extract one column, right, you just need to do your df. Why? Because that's where we stored our data frame inside the df variable. So df dot the column, if it's a one name dot column, to extract that column. And you can see that the column values are 22, 35, and 58. That's the marks column. Or you can do it like this, so square brackets and then quotation marks, because they're strings. All column names are strings. Then if I run that, that is what I get. Right, and then you can create a series from scratch as well. Remember, we said a series is a single column, right? So each column is a series. Then if there are many columns and rows, then you get a data frame. So creating a series on its own, you can also do pd.series and then pass in the values of your series and then the name of that given series, right? So if I run this, that is what I get, right? So I can see that the name is age, and then these are the values of my given series. Then if you want to check the first two elements of your data frame, what we stored inside df or whichever number of rows in your data frame, then you need to use the dot head. We'll explore this in the future classes or in the future sessions. If I run that, I get the first two out. And then the f.tail. So the dot head gives you the numbers from the top. So starting from 0, 1, 2, 3, how many number of rows do you need to see? and then the dot tail gives you the bottom, from the bottom. So starting from the negative going upwards. So if I run that, that is what I get. So if I put in 2 on here, it will get me the last 2 rows. And then df.describe, this will give you a statistical summary of your data, basically on the integer or float columns. So remember, statistical summaries cannot be of your name column, right? You cannot have the count, the standard deviation of your name or the mean of your name and so on. So all we'll have at this point is our max column, and that is what we get on here. Again, we'll look at this in the future classes. So it'll give me a count of 3, and then the mean of these elements is 38. So 52, what are our values? So 35 plus 58 plus 22 divided by 3, that should give you this. Then the standard deviation, the minimum value, and that's definitely 22, the 25th percentile of our column, the 50th percentile, the 75th percentile, and the maximum or the most or the highest number. Right, and then to see a summary of your data set, we use the df.info. So if I run this, I get a summary of my data set. The first one is the index of your column. So the name is at 0, and then 1 is max, and then 2 is your gender, and then how many null values are in that column, and the data type of that given column, right? So that gives you a gist of the kind of data that you are working with. Right, and then one other important thing is how to read your files, your different files, because you'll work with data sets from different files, either stored in CSV, spreadsheets, data in databases. So how do we go about that? And the key is usually the pd.read CSV. So I do have some data stored on my end in different formats, and that's what we're going to be playing around with. And then we have data slash, that's where my folder is, that's the name of my folder, that's called data, then slash the name of your file, what you need readed. So remember, we are reading a CSV file, so I'll call in pd.read CSV, and then if I check the head, this is how my data set looks like. Right, and then reading from an Excel sheet, if you have your data from Excel sheet and you want to work through it in Python, we have telecom Excel equals to read Excel, then pass in the name of your, or the location of the path to your file, including your file name and the file extension. If it's a .csv, include that. And then the sheet name, normally you have many sheets in your Excel files or G sheets. So in this case, I want to read customers, and this is what I would get in return. We also have how to read from JSON, and you can see the trend is the same. If it's reading from CSV, the function is read CSV. So we have read JSON. If I run this, I'm reading from the JSON file. And then one final one is the SQL one, but I'm not connected to my database right now, so I'll just give a rough overview of how to kind of do it. But the first thing you need to install, in this case I was demonstrating using SQLite, so you just need to have your MySQL installed. That's the Python MySQL. So basically your Python being able to communicate with your SQL files or with your database. Then after you've done that, you're going to import this and then set, this is the most important part where you set up a connection. So you just do MySQL.connect. This is a function that exists within this given within this given function, library, and then pass in the host name. Most of the time it's usually localhost unless you're working for like a company, and then the port, and then the user. All this information is usually provided when you're creating your database, then the password of your database, and then the database that you need to connect to, and then the character set. So if you run this, it should display your items on there. And then from that, then you can create a query. We'll be looking at SQL next week, so I think that will be more relevant next week for you to actually display that. So there's a pandas tutorial attached on here that you can check out, and plus the documentation for you to actually understand what that means and what pandas is in general, right? And finally, we also have data visualization libraries that again will cover in depth in future, and that's Seaborn and Matplotlib. So basically, Matplotlib is the base of visualization in Python, and then Seaborn is built on top of Matplotlib. When we say built on top of, is basically the source code of one library being used to build another library or another function or another piece of code. So again, the usual drill, import it as SNS. SNS is the standard alias for Seaborn. PLT is the standard alias for Matplotlib. So if I run this, then the percentage sign Matplotlib inline, this ensures that everything I visualize is within the canvas that I have created. Because remember, to draw anything, you need a canvas. So for everything to remain within the canvas, that is how you kind of do it. So we're going to try and import. Oh yeah, we already imported it. Yeah, we imported it. So I'm going to just roughly, just to show how visualizations in a notebook and in Python look like. Again, we'll cover this in depth in future. I'm going to play around with one. Seaborn offers kind of playground data sets. So that's sns.get dataset names. So we're going to select the planets dataset, right? Just to see how that works out. And then we're going to display the first 5 rows using the dot head that we've just learnt about in pandas. And then just to create a simple visualization on this, just to see how visualizations look like, I'm going to import another data set called tips. That's this data set on here, right? So this tips data set is created within the Seaborn library. So we can just play around with that. So I can run this just to see how that looks like. And there's so many plots that you can create with Seaborn. Again, the documentation is on here for you to kind of see. When you click on that, for you to kind of see how many plots, how to create. It also gives you sample codes with the documentation that I've attached on there for you to actually understand how to build or create that. Right, and let's see creating kind of a distribution plot, another data set. We're going to now select the penguins data set, and we're going to have the x as our flipper length. That's the x and the y, the normal graph. That's your x and your y that you need to plot. And this is what we have, right? So that tells us our data set ranges, the distribution of our data set ranges from 160 something to around 230. Sorry, yeah, to around 230 millimeters. Yeah, so basically that's just a rough of how our visualizations look like in Python. And again, we'll get in depth to this when we are looking at the EDA and the data processing session or lesson. Yeah, and I guess that said, I think we can wrap it up at that, unless we have anything else.
Thank you very much, Dee, for a wonderful presentation. Let me just stop recording so that we thank you for